All right. So, there's example 1. Let's go through it together. Okay? Again, you guys can choose whether or not you write it down. I'm giving you the option today. All right, so it's kind of a review of what we did last week. Where these problems came from is this is an actual unit published by College Board. Okay? Meaning this is going to be this is what they're gearing us up for to take the AP test on. Okay? All right. So, let's try this. So a particle moves in the xy plane so that at any time the position is given by x of t and y of t. They want us to find the velocity vector when t equals 1. So my velocity vector, what's the x component of the velocity vector? What does it say the x component is, guys? Okay, that would be and this would be the position, right? So how do I get velocity out of it? 3t squared plus 8t, right? Okay, what's the y component then? What's the y component? You gotta take the derivative, right? We're doing velocity. 4t cubed minus 3t squared. Now, did we find the velocity vector at t equals 1 yet? No, we need to. What do I need to do to find the velocity vector at t equals 1? Plug in a 1. All right. So what do I get for this first component when I plug a 1 in? What's the whole thing? 11. There you go. Okay. What do I get for the y component when I plug in a 1? You get 1. So there's my velocity vector when t equals 1. Okay. All right, let's try to get the acceleration vector. So my acceleration vector, I'm going to take the derivative of the velocity. So what's the derivative of the x component?
6t plus 8.
6t plus 8. What's the derivative of the y component?
12t squared minus 6t.
Minus 6t. All right, and then what do I have to do to find this when t equals 2? Plug it in. So let's see. 6 times 2 plus 8 is what? Is it 20?
Yeah, 20.
Okay. Alright, and then when I plug 2 into the y component, what do we end up with? 36? Alright, we good with example 1?
That's it?
That's it.
This is going to be a test?
Probably.
What's the name of this?
This is vectors with acceleration velocity.
That's what we're doing.
Alright. A particle moves in the xy plane, so this is our second one. You'll notice it says no calculator. So that at any time t is greater than 0, the position of the particle is given by x of t and y of t. It wants us to find the magnitude of the velocity vector when t equals 1.
Right.
So first thing I got to do is find the velocity vector. So what do I have to do to get velocity vector? Derivative. Okay, so what's the derivative of the x component? 2t plus 3. What's the derivative of the y component? Minus 6t. Good. All right, so to get the magnitude, all right, remember I take the square root of each of the components squared. So I'm going to put the 2t plus 3 in there, and the 3, I did something wrong. 3t squared, right? 3t squared minus 6t. So now, the good news is they gave us a value to plug in there, so I don't have to do anything with this other than plug in the number.
Yeah.
So v of 1 equals the square root of 2 times 1 plus 3 squared plus 3 times 1 squared minus 6 times 1. Okay, so everybody, I want everybody to figure out that number right now. So everybody's gonna figure out what that number is. Whether you're doing it in your head or on your paper, don't shout out the answer yet. Everybody figure out the number. All right, do we have a number yet?
Yeah,
What is it?
34.
Should be square root of 34, right?
Oh yeah.
Okay, we good? Everybody good with that one? All right, example 3. So it says a particle moves on the xy plane so that there's something missing on this. Hang on. Oh, something is totally missing on the bottom of that. Sex the x-axis twice. I don't know why my part of mine's missing. Hang on.
Is it possible to look at this again or no?
To look at what again?
Like what you're going over?
What I'm going over? I'm recording it.
Oh, so you'll put it on the website.
I'll put it on the website, yeah. Alright. Hold on. Let me get to... Let me go to... Not there. Let's do this.
And then I do that. It only goes so long.
Part of the problem's missing, so I don't want part of the problem to be missing.
Feels like being spread out. Is that? Zach.
What?
3. There it is. Okay.
No. Girl, like opened up. Can you put your hand all over it?
Are you mad that the
Go ahead, try.
has a cock?
Try putting your hand all over it.
Dude, I can't.
Okay, now I've got the problem. Okay, so let's talk about... That doesn't seem... Something's wrong.
This is the last one.
Yeah, this is the last one. Okay.
Good.
Alright, so we've got a particle moves in the xy plane so that we have this x component and this y component. Shh, you guys are listening. And they give us an interval. Whenever we see an interval like that, what does that mean we probably need to do? We're probably going to do some kind of integration, okay? The path of the particle intersects the x-axis twice. We're supposed to write an expression that represents the distance traveled by the particle when between the two x-intercepts, but we're not going to evaluate it, all right? Remember our distance traveled that we learned last week, okay? Was we have to go from some a to some b, and we take the square root of the derivative of the x component squared plus the derivative of the y component squared dt. Alright, so let's see if we can get our derivative pieces in there, and then we'll talk about the limits, because the limit is not from 0 to 2 pi. So, if I'm going to look at my x component, what's the derivative of the x component? What's the derivative of this thing here, guys? What's the square root of 3? What's its derivative? Isn't it a number? So it's 0. Okay, what's the derivative of negative 4 cosine t? Derivative of cosine is negative sine, right? So it's going to go positive 4 sine t, and we're going to square it. Okay, what's the derivative of this y component right here? Negative 2 cosine t, good. Square it. dt. Now I need to find the limits. So the limits is where it's going to be intersecting the x-axis is what it said. Okay? So what I wrote down from last year was it looks like I took this one here and I found its intersections on the x-axis. So 1 minus 2 sine t equals 0. So negative 2 sine t equals negative 1. So sine t equals 1/2. So where are the values where the sine, the y value on your unit circle is equal to 1/2? Which two places? There's one of them right there, right? Yeah, I like pi over 6, I heard, and 5 pi over 6. And then those are going to become your limits. Okay? And that's it for today. That's all we're going to do today. Okay? Because it says do not evaluate, right? Because we're doing some of those wonderful AP problems where we don't have to evaluate them, we just have to set them up. Okay? Alright, so here's what's going to happen. I'm going to release your screens.